Welcome to the official YouTube channel of iMostic Circuits. Please visit our official website www.imostic.in for online purchases and all documentation. Hello everyone, in this video we will demonstrate how to start using the Fusion board. We shall implement a very simple circuit which includes setting up an interconnection between the onboard microcontroller and the FPGA. The circuit uses onboard LEDs and switches. And for microcontroller and FPGA interconnection, we have the dedicated 16-pin header J02. Here, please take a note, no other header can be used for microcontroller and FPGA interconnection because the microcontroller is running in 5 volt, whereas the FPGA I/O lines are using 3.3 volts. So for the I/O voltage compatibility, we have implemented a voltage divider circuit at J02 header. Coming back to the demonstration circuit, we have as components on microcontroller side 3 LEDs, on FPGA side we have 4 LEDs, 2 tact switches and a 4-way slide switch, and of course 3 lines of J02 for MCU FPGA interconnection. For using the physical board, you need 2 dedicated micro USB cables, one for the microcontroller programming and communication and another for the FPGA programming and communication with a PC. Note here at the FPGA side, we have this slider switch to toggle between programming and communication modes. For programming, we need 3 softwares: Arduino IDE for microcontroller, Xilinx IDE for Verilog and VHDL coding, and our serial programmer for Fusion board programming. We have dedicated videos on each of them to make your job pretty easy. The microcontroller or the MCU used on this board is Atmega 328PB, which can be programmed using the Arduino IDE. For this example, we have already drafted the code. For Fusion board, you can get all IDE pin numbers from our board user guide. Here we have tabulated all the relevant information about all the MCU pins used on every header. For the FPGA side, apart from the tabulated information, we have provided all the pin mappings. In this code, we simply assign the status of the output pins connected to L5, L6 and L7 LEDs to the status of the input pins PD2, PD3 and PC5 respectively. Let's check if the code compiles without error. Compiled. Now before uploading, choose the board as Atmega 328PB external clock and of course the correct port. Once chosen the correct combination, the status bar shows device connected. Now let's upload the code. Okay, we are done uploading here. For validating, I am manually making the input ports as high using this jumper wire. Look, the code seems working properly. The LEDs are responding to my input. Now let's code the FPGA. Xilinx IDE 14.7 is the latest you can use for Spartan 3A series FPGA coding, but it needs the VMware environment if you have a Windows PC. We will create a new project. Let's call it FPGA MCU example. Keep the configurations as we have shown here on the screen. Now let's create a Verilog code file. We can mention the port definitions here itself, but it is preferable to do it later in the code area. So here first we do IO port declaration, then register and wire initialization. Then we generate a clock divider and finally we have done port assignments. We have assigned very simple logical combination of input switches to define output LED's status. Now that we have finalized the code, we can generate the UCF file for pin mapping with the ports declared. The UCF code can be simply copied from the generic Fusion pin mapping file shown earlier. It is time to assign a strategy so that we can generate the binary file directly. So, go to Projects, Design Goals and Strategy, browse your predefined strategy. Ensure you have chosen the correct strategy. Then apply. Before we generate any binary file, see how many files are there in the directory folder. Now we synthesize and generate the binary files. If we go to the directory now, we see a lot of files have been generated for different purposes, but we are interested only in the binary files generated. Also under synthesis, a schematic file is generated. To ensure you have correctly designed, go through the schematic as well. Now let's upload the code into the FPGA using our serial programmer. Choose the right port, ensure FPGA side toggle switch is in the programming mode, and connect. Locate the binary files to be uploaded. Let's upload only to the FPGA. Done. Now let's sort the MCU and FPGA pins used in our code. In PCB, we have the switches in high state at off conditions. So the LEDs on the MCU side are turning on as we sort the pins. Now let's verify the same by toggling the slider. Looks good. Let's validate the FPGA side code. L1 LED controlled by the SW1 text switch having logical ending with the S1 slider. Verified. SW2 in logical ORing with S2. Verified. LED L3 blinks for the clock dividing register when S3 is off, that is in high state. L4 blinks when S4 is on, that is in low state. On pressing the reset switch, all LEDs get turned off. As we can see, our circuit is fully implemented. So that's it for the video. See our other videos for better understanding of Fusion Board and improve your overall knowledge of FPGA. Thank you.